In this video, I'll go through this example, solving this. So here, State Route 201, north of I-71, the road is really hilly. And there are some hills where, as you go across the top of the hill, your car almost leaves the ground. And I'm guessing that if you were going 65 miles an hour, you really would leave the ground as you went over the top of the hills. So then the question is, what is the radius of curvature of the road over the top of the hills? So what that means is, if the road looks like this, and your car is driving along it, the radius of curvature would be the radius of this part of the circle. So if you imagine this being a circle, the center of that circle, this would be the radius of curvature. So we're going to look for the radius of curvature where a car going across here at 65 miles an hour would just leave the ground. This is another one of those problems where it looks like you really don't have enough information. But let's see what we can do. We need knowns, unknown. Well, let's see, the known we're given, V is 65 miles per hour, and we're looking for R. There we go. Well, the first thing I want to do is 65 miles per hour. I don't want miles per hour because I want to use SI units. So I need to convert. So 65 miles per hour is actually 29 meters per second. Alright, so what else do we know? You know what this looks like? This got a radius here, there's a curve. This looks like circular motion. So we're going to try using circular motion. So there's circular motion here. With circular motion, I know centripetal force is mv squared over r. And I know centripetal acceleration is v squared over r. Those might come in handy. I have an r. Oh, I have a v. I have a v and an r. Centripetal acceleration. I can find what the centripetal acceleration is. Okay. So this is 29 meters per second squared over r. Oh, I can't find what it is because I don't know what r is. R is what I'm looking for. So that hasn't helped yet. I need to figure out what this A is. If I can figure out what this A is, then I can figure out what R is. All right, how do I figure out A? Maybe I should also point out that this is the direction of centripetal force. It's also the direction of centripetal acceleration. So we know they're downward, and we know these are the values. Well, there's a force and an arrow. Maybe I should do a free body diagram. Let's try that. So free body diagram of the car. I have mg. There's a normal force from the road. It doesn't say whether we're speeding up or slowing down. I guess we're just going a constant speed across here. So I don't need to really worry about forces this direction. Besides, if what I'm interested in is this force here, the acceleration there, really I should focus on the vertical direction. So let's do that. So the normal force is up, mg is down. Mg, well I don't know m. What's the normal force? If you are just starting to leave the ground, what does that mean? Remember we talked about apparent weight. So apparent weight that's how much you feel like you weigh. So if I'm standing on the ground right now, my apparent weight is the same as my weight. If I'm in an elevator that's accelerating down or accelerating up, it'll be different. If it's just starting to leave the ground, that means your apparent weight is 0. So if your apparent weight is 0, that means the ground isn't actually pushing up on you at all. You're just like, you're floating across the ground there, just starting to leave it. that means the normal force is 0. So if the normal force is 0, then actually your free body diagram is just that. You might be tempted to add in a centripetal force. Centripetal force isn't some new kind of force that you add to your free body diagram. The other forces that you already know about have to create this centripetal force to make something move in a circle. Before we looked at a ball spinning on a string, where the tension is what created the centripetal force. This time, there is only one force on the car. Gravity has to be what is creating the centripetal force. So this mg has to be equal to the centripetal force. So centripetal force is mv squared over r. So mg equals mv squared over r. If I divide both sides by m, that means g equals v squared over r. Oh, that's interesting.